Welcome to the University of Vermont College of Engineering and Mathematical Sciences site designed to help you with our eWeek engineering competitions. This photo story is dedicated to both pasta bridge and wooden truss competitions. We want you to consider a career in engineering. Engineers solve people's problems and make the world a better place. Environmental engineers work with the environment. Electrical engineers work with all types of electrical systems. The focus of this problem set is designed to build bridges and trusses. This falls under civil engineering. Civil engineers are the people who design roads, airport infrastructure, bridges, and many other projects that help people move and live better. Think how different the world would be without bridges or trusses. Trusses are used in house construction. Trusses are more efficient than using solid wood or steel construction. Many bridges use combinations of trusses. First, we will look at some bridges and truss structures. Then we will work on how mathematical modeling is done to help design trusses and bridges. Then we will work on fabrication and how to build your designs. That will take place in the second part of the series. After that, we will look at testing what you have created. This is a two-part series, and this is part one. Let's get started. This is the Pont de Quebec and is the world's longest truss bridge. Notice that its design uses several different types of truss elements. Notice also that each of the larger members is a truss unto itself. This is the Astoria Bridge in Oregon of the United States. It also is a variety of truss elements in the design. This is St. Mary's Bridge in Fort Wayne, Indiana. Each side of the span is a truss, but also the horizontal and vertical members that you can see are made up of truss designs. This is a more efficient use of steel and reduces the weight that the structure has to support just holding itself up. When the bridge was designed more than 100 years ago, this was a fairly state-of-the-art technology. See if you can figure out which members are in compression and which are in tension. We'll talk more about that later. This is one of my favorite bridges in the whole world. It's the Brooklyn Bridge in New York City. It was originally designed by an army of engineers doing mathematical calculations with pencil and paper. They were led by Mr. Roblin and his son. When the father died and the son became incapacitated, both because of their work on this project, the son's wife took over the project, Mrs. Roblin, and she changed the design. It was her addition of the truss structure to the deck that made the bridge a success. Without it, it would have failed. It was an engineering marvel of its day and continues to operate as she designed it to do. She's one of the great engineers of the last 200 years. Now we're going to look at mathematical modeling. There are several different programs that are available that you can use for mathematical modeling. Numbers are much easier to push around than bricks, mortar, and wood. They are also much less expensive. Engineers use all types of mathematical modeling to test and develop their designs. There are many tools available to design trusses and bridges that are available for free online. However, I recommend using the West Point Bridge Design software. This is a free shareware, and you can download it onto your computer. For the purpose of using it, we're going to be using it to test your bridge and truss designs. And I have several recommendations in how to do that. You can also enter the West Point Bridge Engineering Competition, which is held each year, and become eligible for scholarship money that is transferable to other colleges. First, you need to download the software or see if your school already has it. You can talk to your computer technology people, or you can download it onto your own PC. Then, once you've downloaded it, you will go to step 3 in developing a new design. I recommend choosing a deck elevation in the upper left of either 6 or 8 meters. This will keep your design simpler and there will be fewer joints in the deck, and that will make it easier to build when you actually start fabricating it. Some of these designs, if you look at the upper left-hand side, you will see the program has 6 pre-developed templates of different types of trusses that you can choose from. Some of these designs were developed almost 200 years ago, but are still design standards today. I recommend looking through them just to give yourself an understanding of what engineers have done before you. No necessity to reinvent the wheel. These are more sophisticated designs than the ones pre-developed into West Point Bridge software. The Baltimore, Pennsylvania, or Petit Truss, and the K truss. All of these are used in American bridges for the last 100 years. Once you have picked what type of bridge you want to develop, you can use the West Point software and find the toolbox. First, click on the joint tool. The joint tool looks like an open circle. You can then move the crosshairs around the drawing and place joints by clicking wherever you want them. Note you can also use the eraser tool if you place too many joints and want to erase some. You can also click on the arrow tool and you can move joints that you've placed around very easily. Once you've developed your design, you can add structural members, choose the tool that looks like a steel bar, and click and drag it between joints. Once you have placed all of your members, you are ready to test your design. To do this, click on the little drawing of a truck in the upper left-hand menu. When you are done testing, you can go back to the drawing board by clicking on the drawing of drafting tools next to the truck. I'm sure that you will go back and forth between these two options many, many times. When you're placing members, remember that you have to click from one joint to the next. Even if all the joints are in a row, most of the time you can't just string a whole bunch of members individually. Sometimes that will cause your bridge to fail. In testing it, you click on the truck icon and you will see a truck try to drive across your bridge. This is kind of fun. If the design fails, you'll notice the truck will end up in the river below. In this drawing, the truck has made it across the design. The members in red are in compression, being pushed together. The members in blue are in tension, being pulled apart. Notice that some members change color as the truck is moving. These may go from tension to compression and back again. In truss design, the top members of the structure are called the top chord. Notice that they are all in compression. The bottom members are called the bottom chord and are in tension. The darker the colors, the larger the relative stress on the member. Which members in this bridge do you think the engineers that designed it thought would be in compression and tension? How can you tell them apart? In the drawing board mode, you can click on a joint and drag it to move it. See how this impacts both the cost of your design and the stress on the members themselves. You can check out the stresses by pulling out the chart on the right side of the drawing board. If you click on a member, it will highlight it on both the drawing and in the chart. The chart will tell you the relative strength of the member in both compression and tension. These numbers will be between 0 and 0.99. If the number goes above 0.99, that means that the member has failed and they will be highlighted in red. Do you think steel is stronger in tension or compression? Look at your design in the chart and you should be able to figure that out. You should use this tool to determine which of your members need to be relatively stronger or can be less beefy. This will improve the efficiency of your design by both making it lighter and also making it less expensive. This concludes this photo story. Our hope is that the photo story will help you get ready for the eWeek competitions held each spring at the University of Vermont, College of Engineering and Mathematical Science. This competition was designed to help you develop the skills that will prepare you to do the work of an engineer. All types of engineers develop models, test them using mathematical modeling and/or software, develop many iterations of their work, and then develop their final designs. We hope to see you at this year's eWeek events. Engineers are working on solutions to people's needs worldwide to help them solve their problems. This is Tom Taylor saying that engineering rocks my world. I hope it does for you too.